My name is Maxim Grigoriev. I work for Fermi National Laboratory. It's a big laboratory in the western suburbs of Chicago, and basically it was host for the largest accelerator in the world until it was shut down, and the largest accelerator in the world right now in Europe. So this is the prehistory. And the talk is actually about building some scalable web portal and trying to utilize the best tool for the specific task without, trying to marginalize one tool or one language, or trying to use single language or a single tool as, one tool fit all kind of approach, which, several, like, if you look on like any other community, it doesn't matter if it's Perl, Python, Ruby, and people have this tendency to, pursue this path where they know like one language and they're trying to build everything. And sometimes it's not really maybe the best tool or best language or best framework, best environment for the task. Okay, let's start. So basically, we have this kind of problem. We have 12 national research labs connected by multi-10 gig redundant backbone. And we need to build some kind of monitoring, framework for this whole thing. I mean, and the building framework, the monitoring this thing is not a big problem. It's just, takes time and, your tools if you more or less know about networking. The problem is then to aggregate this data, correlate this data, and show this data in more or less, comfortable way so the people who, for example, moving data on the network, they can, find out at least some kind of information which would then help to identify any kind of performance problem with the data movement, or it will help them to at least isolate the problem, and in this case they can, for example, find that the problem not on the network, and they move in data, and the problem is actually with the end host, which is kind of, you limiting, you isolate, you just, trying to minimize the problem, basically. And this whole thing is, what is Department of Energy, for example, who funds this network and all the laboratories? Actually, it's the biggest sponsor of the science in this country. Yeah, the biggest one. If tomorrow Department of Energy, which is kind of funny name, for someone who funds, some entity which funds science, stops doing, stops funding, then basically there will be no science in the United States. And what kind of data? Basically, the scientific data is a huge amount of data. So people moving data all the time, increase annual 72%, it's petabytes of data, essentially. 100 gigabit network is already here. Like last year, it was like first demonstration, and terabytes of data, you can transfer them. It's the same way as like 7 years ago, it was 10 gigabit network, right now it's 100 gigabit, so you can imagine like where we're going. Technology, like the Moore law, it kind of applies to everything. Not only to CPUs and the number of transistors per square inch, it's actually true for networking as well. And it's, it's level of magnitude. So you have to monitor it, you have to make sure that everything is well provisioned. It's not only issue of the scientific data movement, it's actually any ISP provider in the country experiencing the same kind of, problems. And especially like with IPv6 coming, it's even worse problems because, IPv6 is much more complex than IPv4, obviously. So what kind of monitoring? So we have 400 distributed web services completely decentralized. They just wrappers on top of well-known tools to monitor network. Round trip time, throughput, one-way delay, counters from every switch, every router along the path. Anything you can get, trace route. To understand like how path it goes. So basically, we're trying to get everything possible to create this kind of, like CAT scan, kind of tomography of the network. So of course, the biggest problem, again, in this case is how to aggregate. So, and it's not only like, if you have, this is the monitoring data. In your case, in your type of job you're doing, it could be something else. It could be processing of, I don't know, like trading company data, or processing or analyzing, trying to aggregate some reporting data from anything. I mean, anytime you're dealing with vast amount of time series or observations-based data, for example, running some simulations, running some tests, the problem will be the same. And in my case, it's about like 21,000 unique measurements. They schedule it from the tests from the previous slide. They schedule it to run from anything from 1 minute to 4 hours. And again, it's decentralized. So basically, the system, which, of course, gathers all this information, it doesn't control anything. It just assumes that some data will be there. So basically, you kind of assume that you're not going to get anything, probably, or some part of it. You just have to build your system based on the assumption that something will be there or maybe not, which is, I mean, kind of interesting. So it's like 200 million time series data per month right now. The goal is that it has to be kind of, you know, it has to scale horizontally. It should be able to run anywhere, ideally. You shouldn't be like constrained by some monolithic application running on, you know, a single host, or only this architecture solution where you place your application on, you know, web server, and then you kind of stuck with this, and you have to, you basically, your approach to scale is only to replicate this on n kind of number of hosts, put it behind the load balancer, and that's it. But then, I mean, again, it's still monolithic application. So also, because of the decentralized nature, it has to kind of be able to, you know, spawn hundreds of asynchronous requests, get some data, process it, and only be limited like by the response from the like longest response, single longest response. That's all. So it's kind of another constraint. And plus, I mean, because users come into the web portal, and the thing before that, like in the previous slide, it was more about like, okay, how we gather data. Right now, what are we going to do with this data? So, I mean, you can imagine, so it's a data-driven portal, plus it's a user's content-driven portal in terms that you have to provide some environment where a user can, you know, see something, embed what he just saw into some kind of rich media, post it, get some advices. I mean, you know the examples on the web. I mean, like basically the communities where you can get help. I mean, very easily. It's kind of the same idea. I mean, and plus, I mean, it would be nice because, again, it's kind of environment of 10 different laboratories. They don't really talk one with each other, so basically you have to create this place where they can exchange some knowledge or some progress on some project as well. And of course, authorization, authentication, since the Department of Energy, I mean, it's kind of important as well. And let's build it on open source. So Linux, Perl, Drupal for the front end, PHP, of course, because Drupal is PHP. And why not to build it on Perl like everything? The problem is, for example, Drupal is a very mature product. Perl doesn't have even comparable by the functionality framework, content management system at all. So Gearman, let's use something for the job submission, something which allows us to spawn these hundreds of remote requests. MySQL, I mean, MySQL is not really open source. Quasi, I mean, you can call it open source, but what are our choices? So let's stick with MySQL for now. Git, because, I mean, yes, it's Git. It was SVK maybe a little bit a while, SVN before that. Right now it's Git, I mean, that's what people use. Front end, you want to build something very fluid, something where like all information will be correlated, so you have a lot of flexibility here. In our case, we built it on jQuery, jQuery for the charts, Raphael for the subway maps. I will show it, and OpenLayers for the geographical maps. And basically, we tried kind of the synchronized events through all of them, and it was kind of a big issue. And it's REST. So basically, the whole framework works on REST. Any kind of request can be sent to the data source or to the visual front-end visualization with the same parameters. You'll just get different view of the same data. Perl, yes, it's a model. I mean, Perl Moose DBX class. Dancer is a RESTful API because, I mean, it just doesn't make sense to code this. I mean, you have to think about support model basically. Finding Perl developer is very hard. Finding like advanced Perl developer who can go through obfuscated code is even harder. So ideally, if you're looking for the support model long term, then your code has to be as clean as possible, as simple as possible, and you have to again build not the monolithic application with heavy reuse, but something much lighter. Basically, API with a single purpose, very lightweight. I mean, it's better to build several APIs than one with a heavy reuse because supporting it will be way, way, way harder. So that's kind of the approach here. Basically, that's the monolithic. I mean, again, it's kind of anti-pattern. It's became one. It's not really specific. Building monolithic APIs is not really specific to the Perl. I mean, I know several examples of Java J2EE applications which was built 7 years ago, and right now people trying to desperately to slice and dice to them into a collection of much lighter web services because they don't scale. First, support is just, I mean, you're really looking for very experienced Java developer. It's a lot of money. So long-term support is very expensive. Heavy reuse, which is basically synonymous to monolithic, object-oriented kind of API. Again, it's a huge anti-pattern. I mean, because it's so hard to support. That's unfortunately what we discovered, and not only in this project. So what is a Drupal? I mean, if you know what it is, it's kind of, I mean, you can go to the website, but basically there are a lot of sites, some of them from top 10K sites. So basically it used on very heavy sites with very heavy traffic, multiple users communities. I mean, whitehouse.gov is maybe the most known site. Drupal 7 is the most recent release. It's open source to the bone. It's GPL. You have to stick with GPL on Drupal. There is no way to go with Apache license on BSD license. Unfortunately, so for example, if you think about using it on a project, you have to think twice because of the licensing issues. I mean, they're very, very, very specific about keeping it as a community-driven open source project. Perl. We use Perl where it really shows its best qualities. It's a backend, REST web services. I mean, again, if you try to utilize it everywhere, we would probably achieve the same goal, but I mean, it's not the goal we were trying to achieve. The goal was to create a scalable application first with a long-term support model second, but not least important. And with Perl, usually you want to, again, minimize usage to the very light kind of services. I mean, it's the same, like, for example, you can consider writing a huge web portal on Java. So you have to use JSP on the front end, Tomcat, of course, I mean, container, and a lot of Java code on the back end. At some point, you want to reuse a bunch of stuff, and it's the same. Monolithic, very heavy reuse, very hard to support. The same is like right now, for example, I mean, I'm pretty much sure all of you heard about Node.js, right? Very nice backend, very low latency, very small memory footprint, very scalable. But I mean, and kind of again, nice idea. Oh, you have JavaScript application. You have already JavaScript API on the front end. Why not reuse some of them on the back end? Add some database connectors, add some stuff because it's all callback based. I mean, it's basically the same event loop already there, and I mean, it's nice, it's good. It's basically right now used on many, not many, but it will be used on many gaming online massive parallel sites where basically you have to update a lot of stuff at once. But I can see like how it's going to end up in the same boat with any other API. So because you'll start reusing a lot of API components from front end to the back end, back forth, and you might end up with a problem as well. So, I mean, isolation in this case helps much more than this ability, an inherited ability with any actually object-oriented language, the inherited ability to reuse code. We use Perl ORM. Again, don't really, try too hard. Use something which, I mean, brings you to the goal with the least effort, with the least learning curve for any followers, for anyone who will be supporting it. You already know SQL probably. DBX is not extremely, DBX class is not extremely known, for translating SQL very well. I mean, for translating what you try to code into the SQL very well. And another problem, like DBI is not extremely, process safe, multi-process safe. So basically, you have to use connect cached, and you have to cache your connection. You have to check that your connection is still up. I mean, it has some problems, but you can use your SQL. So it's a balance. I mean, we usually, like I use on this project for the backend. Like most complex queries usually goes with DBI, and I think it's kind of how everyone else is using. And DBX is mostly for some, more simple selects, because otherwise, like, try to join 5 tables with DBX class. Good luck, and make sure that, I mean, this resulted query will be optimal. Ooh. In MySQL, since we're collecting a lot of data, so I mean. After some, tries and errors path, the use forks found to be the most stable. I mean, basically, our collector, like on the back end, there is a way, like the architecture, which I will describe slightly later. It's pretty simple, basically. You're collecting and trying to prefetch and cache a lot of data. If data is not in database, then, in real time you go and you try to get it from the remote sites. In order to collect it, you use forks, and I mean, it kind of, I mean, it has limited management. So basically, you have to write your own custom pool management, but at least it's very stable. It doesn't have any issues from parallel fork manager for control based modules, and I mean, we're using it heavily. And I mean, and this is the architecture I was talking about. The persona is the name of the distributed web service monitoring web services, and basically the eCenter trying to discover all the services, trying to collect data after the service is discovered, and basically trying to do it in parallel from the multiple instances of the remote services. Only exception is SNMP data and topology data, which is gathered from the single source and basically presents some bottleneck. The rest, the first query you can see, I mean, that's how we try to maintain our clarity about the queries. Basically, the first query will give you data, the second query will give you a visualized view of the data, and you can just almost copy-paste or at least run some very simple client, RESTful client, which can do this. It's kind of and we try to hide all the details. I mean, the src_hub is an equal ANL is the name of the Aragon National Lab. There is no host names, there is no node names. I mean, basically, the part of the aggregating data is matching with basically we use a lot of heuristic to identify that monitoring host is actually located and belongs to the specific hub, what we call it, or specific laboratory. In case of any ISP provider, that would be some subnets. This is the architecture of the portal. We have a lot of features on the UI. It's a user's dashboard, it's visualization. There are a lot of consumers of the data actually on the back end, forecasting service, anomaly detection service, and any other service. Forecasting data service is actually written in Python. Anomaly detection is Perl, I believe with some C++ elements because it requires it. But since everything is REST, it doesn't matter. You can send JSON, and basically we use JSON for internal communications to the German worker nodes as well. So JSON is our universal, very light format for serialization of any piece of data. And this is the dispatch part. Basically, if the DRS, which is data retrieval, centralized engine, which essentially our aggregation engine written in Perl, and it can check if the data is in the cached database or in this scalable MySQL database, or it can go and spawn hundreds of requests to get data from the remote service. And it's implemented, as I said, in Dancer and with, Dancer REST plugin, database, DVIC. The Twiggy was our choice of the PSGI web server. We tried FCGI, Starman, Twiggy, which is based on any event loop. Any event CPN model from CPN model. We found it to be, the most stable, and it was designed. If you go to the CPN, it was designed for the long pool polls for the very long living event-based kind of web server. So it has slightly larger latency than Starman, for example, or a Perl Ball, but it's asynchronous and it's very stable. So that's what we're using, and then we're using Nginx proxy and round robin kind of in a round robin load balance information. So we have 100, 10, 12 servers behind the Nginx, which we can increase because those servers, they're located anywhere. We can run them, doesn't matter where. This is our backend. Essentially, the worker node is a German worker node, and it can query MySQL database in parallel, or it can dispatch to and get data from the remote service as well. And we can, I think right now it's about 20, 30 worker nodes always active. Drupal. So, yeah, Drupal is kind of tricky because if you know someone who knows PHP, doesn't mean this person knows Drupal. And if you know someone who knows Drupal, doesn't mean he knows PHP. That's what we found. Why? Because Drupal 6, for example, it was based on non-event object-oriented PHP. I think it was PHP 3 or something. Very early versions because, it was very long road for the Drupal to mature. And the Drupal 7, so if you can just start with Drupal 7, it's much easier, small learning curve. You can probably find more better people because Drupal 7 right now, it's more popular. People if they're trying to get into the content management systems, Drupal 7 would be the choice. It's very easy to administer. but you really need someone who knows how to create custom Drupal modules, because you will need custom content types if you want to enhance your Drupal system with your own stuff, essentially. Drush is very easy. I mean, basically, right now, our whole site is packaged by Drush, and we use GitHub to download and to deploy everything. It takes about 15 minutes to deploy a whole site with backend, actually. What Drupal is good for? Knowledge base, groups, organic groups, activity streams, top conversations, most active conversations, issues, wikis, forums, ticket tracking. It has everything. It has myriads of already developed modules. Our idea was to make our UI to create it as fluid as possible, to streamline everything. Basically, we were looking on examples available on the internet. We really tried to highlight most critical stuff, to narrow down. Basically, right now, all the charts, you can narrow down one chart, and basically all of the charts will be adjusted. So basically, we try to help user as much as possible. This is our front page view. You can go to ecenter.fnl.gov. Link, I will provide link at the back. And basically, this is how the anonymous view for the user look like. This is how, if you log in and you identify yourself that you belong, for example, to Fermi National Accelerator Lab, that your view will change and you will see a specific view, basically centric to your laboratory, with all the data aggregated from all other laboratories and showing status of the path. There's a single sign-on. We support any kind of available sign-on, plus we support what they call federated single sign-on, provided by Shibboleth. Shibboleth is Internet 2 project to exchange metadata and provide multi-federated single sign-on between different organizations. This is how front-end looks like. So essentially, you see that this is the open layers map. The subway map is Raphael. This is the Jacob plot. If you highlight one event, basically one event gets propagated through the all JavaScript libraries over here. I mean, we try to help user as much as possible by providing like tooltips, trying to explain essentially what he sees on the network, on the view here, and by pressing this button, for example, you can basically create embedded issue, embed all this information into the issue. So you can create network issue from that, and then you can get some help or some kind of comment, something which we hope will help user to isolate problem. And this is the Drupal's very rich editor, which basically you can even embed a YouTube video or any other multimedia. And I mean, again, with Perl, I mean, the Drupal, I think it took them 10 years to, came to this level of functionality. I mean, I can imagine how long it will take for and it's thousands of people community. I mean, I can imagine how long it will take for Perl to create something like that. So why? I mean, if it's already there, it's open source. The community is very nice. I mean, and just, don't stick with one tool, I guess. Problems. So the backend, the storage is MySQL. It's not really scalable enough. It's not built for the time series data. Essentially, if someone today decide to create scalable, with very fast retrieval, linear time, or actually constant times to retrieve data from the time series storage, and with native support for the time series analysis, that would be a very nice idea for the startup, I would say, because time series data is essentially observation data, any observation. It's used anywhere. I don't know about any open source project which would try to do something like that. There are several commercially available options, but it's like IBM, Oracle Exadata. It's very expensive, millions of dollars literally. I mean, MySQL in this case, I would be looking for the NoSQL solution, for example, time series data based on MongoDB, because in this case it could be distributed, scalable. You can add capacity, as fast as you can, if you want. Ideal web services framework. Right now we're using Dancer. Dancer, again, it was developed as one tool to kind of replace maybe Catalyst in some sense. And I mean, web services, when you build in web services framework or architecture, you don't need a lot of things which you don't need view from the MVC. Only you need is a nice implemented model and controller. That's all. So basically, you need very fast JSON XML serializers. You need very stable and process safe, multi-process safe DBX class plugins. It would be nice if it would be some native support for the event loops or like callback-based event loops, asynchronous job submission, messaging queue, because that's then, and of course, yes, low latency, very low memory footprint, high performance HTTP engine to run all this. So this kind of framework, I mean, that would be solution, for example, in case of Perl, if Perl wants to, another nice idea for the project, for example, because this solution would be applied in many, many, many cases, and with good support for very old aged SOAP, at least it will be, I would say commercially interesting to many, many companies. This links. So yeah, it's the code, source code for this, for Perl, for Drupal, for JavaScript on GitHub. The demonstration are actually running. This is how it looks like. Yeah, sorry guys, it took me longer than I thought. So this is the actually active and so yeah, this is the Jacob plot, actually very nice. I mean, if you need something like do you have any questions? Because I'm done. Thanks. And there is a wiki. This is issues. And on top of that, this is actually Drupal administrative interface and content. I mean, if you know Drupal, it's actually pretty easy. And support for groups. jQuery and jQplot. Mm-hmm. And on the GitHub, I mean, all the code, all the JavaScript is on the GitHub, so you can see basically you can take a look on the demo and then just see how how the event loop is actually organized to make it work between these guys. Because yeah, this is the Raphael and this is the Jacob process.
Thank you.
You're welcome.
Have you been pretty happy with Drupal performance?
No.
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 No. Have you done any benchmarking or anything, especially with things like database access?
The database access actually was not